Hello everyone, welcome back to the course Information Theory and Coding. In the today's class, we are going to study one more important Shannon encoding algorithm, and that we call it as a Shannon-Fano encoding algorithm. When compared to the previous algorithm, this Fano algorithm is very simple and you can quickly solve the problem which are associated in conversion of source alphabet into code alphabet. Okay, so let us try to look into the procedure what we need to adopt in order to convert the source alphabet into code alphabet. So the first and foremost thing what procedure you need to adopt is, so the source probabilities values you need to arrange them in a decreasing order of their probabilities. So you will be having a source alphabet and those source symbols you need to arrange them in a decreasing order of their probabilities. Means the highest probability values you need to assign the first, that is you need to represent in first, and the lower probabilities values you need to represent in a subsequent manner. So means what, you need to arrange the source symbols in a decreasing order of their probabilities. The second procedure is that what you're supposed to do is you need to make a two group of the entire symbols what you have in such a way that the sum of those two group it should be equiprobable. So if you divide the given 8 symbols, let's say 4 symbols and 4 symbols, means so the sum of 4 symbol probability should be equal to the sum of the remaining 4 symbols. So you need to group like that. Okay, so the second procedure is you need to divide the source symbols into two groups such that each group should have a same probability values, approximately should have a same probabilities values. It is not necessary that always we need to do the division in equal number of symbols in each group. Depending upon the probabilities, we can have a combination of the source symbols such that the sum of group probabilities has to be equal to approximately equal to the two groups. Okay, so the next step what you are supposed to do is, for the first group you are going to assign the code word as 1, and for the second group, for all the symbols you are going to code or you are going to assign the binary value 0 for that code. Okay, so this is what you're going to do it in the third step. And in the fourth step what you're going to do is, again you are going to consider the first group, again you are going to divide them, again you are going to do the subdivision into two groups such that each sum of source symbol probability has to be same. Again what you do is, for the first subdivision group you are going to arrange or you are going to assign a binary value is equal to 1, and for the second subdivision group you are going to assign a binary value is equal to 2. So this process you are going to repeat unless and until no further division is possible. This process you are going to repeat unless and until there is no further division is possible. So this is the procedure what you are going to adopt in order to solve the Shannon-Fano encoding algorithm. Okay, so I am going to summarize once again. So what you are supposed to do is, first you arrange the source symbols in a decreasing order of their probabilities. Then you need to make a group of two, and each group, that is the sum of probability of the two groups, has to be same. And for the first group you are going to assign a value is equal to 1, and for the second group you are going to assign a value is equal to 2. And in the next step what you're going to do is, the first group you are going to select and again you are going to divide it into two subdivisions. For the first division you are going to assign the value is equal to 1, and for the second group you are going to assign a value is equal to 0. So this division you are going to continue unless and until there is no further division is possible. So this is the procedure what you are going to adopt in the Shannon's Fano encoding algorithm. Okay, so let us try to solve one problem so that it will be easy for you to understand how we can able to solve the Shannon encoding algorithm, that is Shannon-Fano encoding algorithm, to convert the source alphabet into code alphabet. Okay, so let us try to solve this problem. So the given message with three probabilities, construct a binary code by applying a Shannon-Fano encoding procedure, determine the code efficiency and redundancy of the codes, draw the code tree. So you need to construct by using a Shannon-Fano encoding algorithm, and you need to determine the code efficiency, and also you need to draw the code tree. So three important parameters they have applied or they have asked you to solve in this problem. Okay, so first thing is Shannon-Fano encoding algorithm. So what are the symbols they have given you? The symbols they have given you in this manner. Okay, S1, S2, S3, S4, S5, S6, and the probabilities values they have given it is 0.2, 0.2, 0.4, 0.03, 0.07, and 0.1. Okay, So you need to apply Shanon-Fano encoding algorithm. So what is the first step? The first step is you need to arrange the symbols in a decreasing order of their probabilities. So what I should do is I need to arrange the symbols in a decreasing order of their probabilities. So what is the highest value? 0.4, next is 0.2, next is 0.2, next one is 0.07, next one is next one is 0.1, next one is 0.07, next one is 0.7. So I have arranged the source symbol in a decreasing order of their probabilities. Now what I should do is I should group them in two divisions. I should group them in a two divisions such that the probability of the top one should be approximately equal to the probability of the bottom one. Okay, so therefore what I do is what I did is I have grouped the first two symbols. So what is the probability? The probability is 0.06. Okay, and this one is 0.2, 0.1, 0.3, and this will be 0.1. So you'll be getting a 0.6. You'll be getting a 0.6. This is how I have arranged the probabilities. It's not that hard rules you need to stick to this. You can go for other method also. Means you will be arranging this 0.4 and you'll be arranging this in a 0.6 also. That is also possible. Okay. So next, so you have divided them into two groups. Now what is the next step? You need to assign a value, binary value 1 for the top one and 0 for the bottom values you need to assign. So 0 you need to assign the bottom values. Okay, so this is one iteration over. So this iteration has to be continued unless and until further no iteration is possible. So there are two symbols are there, right? So now again I can do the division. Okay, how I can do the division? Since there are only two symbols are there, so one symbol I will be given to 0.4 and one more division what I will be giving is I will be giving it to 0.2. Okay, so the first group I will be assigning the value is equal to 1, and for the second group I will be assigning the value is equal to 0. So the top division is over. No further division is possible, so this will be over. Next one, bottom one. So what you have? 0.2, 0.1, 0.07, 0.07. So what I will do is I will group these three and I will group this one. Okay, if I do that, what we'll be getting is 0.2. Next, the remaining symbols will be 0.1, 0.07, 0.07. So the sum of this probability will be 0.7, 0.07, 0.03 is 0.1, 0.1, 0.1 is 0.2. So 0.2, 0.2, yes, it is equal probable. So for the top probability value, I will be assigning 1. For the bottom value, I will be assigning which is equal to 0, which I will be assigning which is equal to 0. Okay, so now what I will be doing is again this division is possible. So what I will do is I will divide this into first group 0.01 and the remaining 0.07, 0.03 I will be doing it. So for the first division I have assigned the value is equal to 1, and for the lower divisions I will be assigning the value is equal to 0, 0. Again I will be considering these two blocks and I will be dividing 0.07 and 0.03. So you will be getting 0.1, that is for the first probability value will be getting assigning value is equal to 1, and the lower probability value will be assigning a value is equal to 0. So this is how you are going to do the division of the probabilities values through the use of a Shannon's Fano encoding algorithm. After doing the division, so now the next thing what you are supposed to do is you need to find out the code words. So how you are going to find out the code words is, so you can see here for the first symbol 0.04, what are the code words? The code words are 1, 1. The code words are 1, 1. Next, for the second point, what are the code words? 1, 0. So the code words are 1, 0. For the third one, what is that? 0, 1. So the code word is 0, 1. For the fourth one is 0, 0, 1. So therefore 0, 0, 1. The next one is 0, 0, 0, 1. So 0, 0, 0, 1. The last one is 0, 0, 0, 0. So therefore you got it as 0, 0, 0. Okay. So the average length of code words, how many digits are there? 2, 2, 2, 3, 4, 4. Okay. So therefore what you can do is you can find the average length, that is nothing but Li into Pi. So Pi is nothing but this probability values, Li is nothing but this. So if you do the summation and if you substitute all these values, so you'll be getting Li is equal to 2.3 bits per symbols you'll be getting. Similarly, you need to find the entropy of the source. So entropy of the source you are going to calculate by using this expression, that is nothing but h of s is equal to summation I is equal to 1 to 6 pi log 1 by pi. If you do that, so you'll be getting h of s is equal to 2.3 209 bits per symbol you will be getting. So therefore entropy we can calculate, that is h of s divided by L. So what is the value? 2.209 divided by 2.3. If you do that, so you'll be getting the entropy is equal to 9.96.04 you will be getting. Similarly, the redundancy is nothing but 1 minus efficiency. If you do that, so you'll be getting 3.96. One more thing what they have asked is, they asked you to find out the code tree for the given diagram, code tree for the given source symbols. So you are going to use this code vectors in order to find out the code tree. Always you will be assigning a root node. From this root node you will be having a two branch. One is with respect to 0 and one more is with respect to 1. Okay, so 0 1. So there is no any further division is means the symbols you cannot able to find out because minimum two symbols you require. So again I will do the extension 0 1. So when you do that 0 1, the symbol is s2 is there. Next 1 1, your symbol is s1 is there. Next 0 1. So again I will divide this into 0 and 1. So if I start with the root node 0 1, so it is s3. Next 0 0 1, it is s4. Next 0 0 0 1, it is s5. Next 0 0 0 0, it is x6. So this is how you can calculate the code tree of the given vector or a given code alphabet. Okay, so the remaining thing we will see it in the next class. Thank you.